Okay, so into our example, you spin me round, which surprisingly enough, I know you're going to be amazed by this, is dealing with shaft work. So it says determine the torque applied to the shaft of a car that transmits 255 horsepower, that's power, and rotates at a rate of 3,000 rotations per minute. Okay, so one thing I always say you should do is one, write down what you've been given. So power equals 255 horsepower. And let's see, N dot is going to be equal to 3,000 rotations per minute. Now these are not really the best units for us. I should probably go to rotations per second there and probably to kilowatts or watts there to really have an easier time of it. Another thing you should probably do for most of your problems, which I don't always do when I'm doing these examples in a PowerPoint, is write down what you're actually trying to find. So what's the torque? It doesn't have to give me units, but don't have to worry about that. We'll have units at the end. Okay, let's go through it. So the first thing we do is we're going to rearrange our power of a shaft equation to solve for torque. Now we have the power, we got that, we have N dot, 2 pi is just a number, so we can solve this, but do we have it all in the right units? The answer to that is not the best. So first thing we're going to have to do is we're going to have to convert from 255 horsepower to pound-force foot seconds. You're like, that's really the same unit? It is. That's technically work over time, so power. Works out good. And as a note, this is a very helpful conversion. Write it down. You're going to use it a whole lot. Or you can just put in the front cover of your textbook. Don't have a textbook? Get one. Could be helpful to you. And so I get from this that I have 140,250 pound-force foot seconds. The little subscript F right there is saying that this is a force, not a mass. So I plugged that in there, and I went ahead and converted from rotations per minute to rotations per second by saying that there are 60 seconds in 1 minute. And so this comes out to be 446.4 pound-force foot. So not terrible, not too bad. The biggest thing is just understanding those conversions and how we do it. This is one of those like plug and chug examples, which is always pretty nice. Okay, that's it for this time. Thank you so much. I'll see you all soon. Bye-bye.